Hello viewers, in today's class, in the earlier sessions we have discussed about the estimation of quantity. In the earlier classes we have discussed about the estimation of quantity of water, various sources of water, and how to convey the water from the source, how to draw the water from the source. Can we directly use this water? Do you think can we use this water directly, or is the treatment same for all sources? Can we use it directly? Is the treatment same for all sources? What do you think? We cannot use it directly. At the same time, the treatment for the water from different sources is not same. Is the treatment same for all sources? No. The treatment is not same for all the sources. Now, we do not get absolutely pure water anywhere from any of the sources. Absolute pure water is not found in nature, and treatment of water will be different for different sources. Now, it is not essential for us to have completely chemically or physically pure water. It is not necessary for us. Some of the impurities, they will help us. In fact, they these impurities give good taste, and some of the impurities are harmful. They are pathogenic. They are the cause for various diseases. So some of the impurities are good and some of the impurities are bad. So we cannot totally remove all the impurities. We should not in fact remove all the impurities. So the water in which impurities are removed only to a certain extent, such that it is not harmful to human health, is called wholesome water. So what we require is this wholesome water, water in which impurities are removed only to a certain extent, such that it is not harmful to human health, is called wholesome water. So this wholesome water will help us in the assimilation of the food, for digestion, etc., etc. So what are the different, we should know first of all how these impurities are caused, how these impurities are caused. Generally, when during when the rain falls, this rain catches up the dust, various gases like H2S, sulfur dioxide, nitrogen dioxide, etc. These gases are dissolved by the rainwater, and then when it reaches the ground, it will flow as the runoff. When it is flowing as a runoff, it will catch up some dirt, silt, clay, etc. Then animal waste, then pesticides, all these things. It will catch up all these things when it is flowing as a runoff. And thirdly, when it is going as a groundwater, that is when it is being percolated, when it is being collected as groundwater, then what happens? It will go through different layers of the earth. So when it is going as different layers of earth, it will dissolve many organic and inorganic salts naturally when it is passing through different layers. So the groundwater also catches some of these impurities. These are the three ways in which these impurities will get accumulated in various sources. If it is surface source, because it is mainly runoff, it is catching up dirt when it is flowing as a runoff. So these are the major ways in which the water catches up these impurities. Then how can you classify these impurities? Before designing your treatment, I told you, when we were talking about, we cannot directly use this water, we have to treat that water. in which way you are going to treat this water. You should know what are the impurities present in it. How can you classify these impurities? In what ways these impurities are present? So the main you can classify them in two different ways. There are two types of classifications. So when I drink a glass of water, let us take this glass of water. I feel that this glass of water is clean, but this may contain many impurities. This water may contain many impurities. Some are visible. So when I take water, when it is contained, when I put some soil in this, you will immediately silt or something. Those are visible. Now this water is appearing to be very clear. So this is clear water. So similarly, like this, you can classify how these impurities are. That is, whether the impurities are suspended, whether the impurities are dissolved, whether they are in any other form. So let us take the type 1, see the type 1 impurities, that is, the impurities can be either suspended or they can be either dissolved. In this suspended particles, so some you can see like your paper, cloth, etc. They will be in the form of suspended impurities. Paper, cloth, they will float, and some depending upon the velocity, turbulence in the source of water, these suspended impurities will be in motion. So they are visible. So some may settle down, but some may not settle down. So some will be floating, that is the whose specific gravity is less than 1, such particles will float, and the particles whose specific gravity is greater than 1, they will settle down. So, but some of them will be in motion. They will be, you can see them as colloidal particles in the glass of, in the water. So this is about suspended impurities. And coming to the second classification, that is dissolved impurities. These can be various gases, sulfur dioxide, carbon dioxide, etc. Some mineral chemicals, inorganic and organic chemicals, like your sodium chloride. When you mix sodium chloride, that is salt, common salt, you cannot see it, is it not? It is getting dissolved. So like this, there can be impurities which are in dissolved form. So these are the two types. Now then the third, in this suspended particles only, we have whose specific gravity is almost equal to 1. They will be in continuous motion and they possess some electric charges. This is our common experience. For example, on a cold dry day, you will, when you some particles, they give you a slight jerk, slight shock like thing, is it not? That is, all particles, all materials will possess surface static electricity, small charges of static electricity. This static electricity will be there in the particles which are in continuous motion in water. So what happens? Some materials, they will possess positive charge, and some materials, they will exhibit negative charge in the water depending upon the type of the material. So what is happening now? They will repel, the particles, they will repel. The mass of these particles is very, very negligible for such particles. Those particles are called colloidal particles. They are suspended particles only, but they are very, very fine. Their mass is very, very less compared to the electricity charge that they are possessing. Comparatively, this is very high. So what is happening now? They will be in continuously in motion. So you cannot remove them as you cannot screen them as filterable solids, or you cannot make them settle down with the help of some sedimentation tank or something. In any of the ways, you cannot remove these colloidal particles. They require some special treatment. And similarly, these dissolved solids also, dissolved impurities also, you cannot remove these dissolved impurities. You have to use do some extra treatment to them. You have to be such that they become insoluble. Then only you can remove these impurities. These are dissolved impurities. You have another classification. Let us see the second type of classification. This is our common experience, we generally say that the water there is having high fluoride content. This water is smelling very bad. This water is smelling very. This water is tasting very bad. The taste is not good for this water. This is our common experience. Is that this water is smelling chlorine and this is bitter. So this classification is when you are. This is by either physical nature of the water or chemical nature of the water. When it may contain some microorganisms, like when people wash near the source, so it may catch up some bacteriological impurities, so it will contain some bacteria. So the second classification, depending upon their physical nature or chemical nature, or you can classify this. That is, this is the second type of classification. That is, it can have physical impurities. This is, physical impurities, you can sense them, you can taste them, you can smell them, you can see the turbidity, you can see the impurities in it. That is physical impurities. The second one is chemical impurities. These chemical impurities means they possess the chemical characteristics. It will have some chemical impurities. And the third one is bacteriological impurities. That is, if it contains bacteria, then these are called bacteriological impurities. Now we'll have to, so once we have known what are the different impurities present in it, we can go for the treatment. So what kind of treatment? What are the what is the need for? What are the benefits of testing? We have testing the water, testing the quality of water, finding out what impurities are present in water. So what is the use for this? That is, when we test the water, there are when we test this water, we have certain benefits. What are these benefits? That is, you can know the quality of raw water, whether the water is the quality, at least you will know whether the once you go for these tests, you will know if the water is suitable for drinking purposes or not. Then there is another important benefit which we get out of it is, you can design your treatment process according to your impurities. What are the different treatments? You cannot treat the water all the different water from all the different sources similarly. So you can know the treatment. Then for utilizing the water in different industries, like the food and beverage industries, the water should have very good, it should not contain any bacteria, the quality should be very good, the standard that is to be maintained should be in fact more than the potable water. Then the textile industry, the water should not have color. So if it is having color, then it will spoil the dyes of the textile industry. Like this, then if you are using it as a boiler, water for boilers in certain industries, then if it is having hardness, then it will form scales. So we can for different industries, when the usage is different, you will have to go for a different treatment process. So then the next important use of doing this analysis, doing this test is the quality of water. We will know whether it is up to the standard or not, whether it is below the permissible limit or not. So when the water, why the water should be below the permissible limit? If it is below the permissible limit, then you will people from the safety point of view, from the public health point of view, you will not get sudden outbreak of epidemics. That means there will not be any bacteriological impurities. Similarly, it will not have nitrate, the contents, the chemicals which will cause various diseases. So once you treat the water from the public health point of view, the water will be safe. So the next important thing is to once we maintain the quality, you can safely, from the aesthetic point of view, that is, you will feel like drinking the water. even if it is harmless, if the water is not good, if it is having some color, if you feel that it is having some impurities in some particles in it, you will not feel like drinking, is it not? So that means from the aesthetic point of view, we should maintain the standards. Then from the economic point of view also, this is very important. That is, you cannot treat your water at house. So once the water which we are getting is, if you think that it is safe, then you can safely feel like drinking the water. And from the economic point of view, that is, you need not purify it at your house by boiling or by some treatment, for some way of treating the water. You need not treat that water again at your house. So from the economic point of view also, you will if the water standard is maintained, it will be useful. So that is why we will maintain the standards. We go for this test for this following benefits. Now, what are the different physical tests that we do? That is, we will go for different physical. That is, physical test means we will test for the turbidity. We will test for turbidity is the presence of particles. The water, the presence of, due to some presence of particles, it will contain turbidity. From the color, we will test the color, then we will test the taste and odor, and then we will see the temperature also. So let us first see the turbidity. So what is turbid water, turbidity? Why is it caused? The presence of the suspended matter is the presence of certain particles will cause turbidity. Initially, so we will see suspension of particles in water interfering the passage of light waves and scattering the same is turbidity. What is turbidity? The suspension of particles in water interfering the passage of light waves and scattering these light waves is the turbidity. Scattering the same is scattering the light waves is turbidity. So how do we measure the turbidity? So we will see, we can measure turbidity in when we have certain instruments to measure the turbidity. The oldest instrument was a turbidity rod. Using this turbidity rod, it will have a platinum needle at the end, and when you dip this rod in water, you will directly, now it is actually obsolete. Now we are not using that instrument. It will directly, it is a graduated scale, it will have a graduated scale, and you can directly get the reading of turbidity. This turbidity is measured as parts per million of the impurities. That is, the parts per million the impurity is present in these many parts, that is in milligrams. In 1 milligram per liter is called 1 part per 1 ppm, that is parts per million. Now when you dip this rod at one particular stage, you will not find the needle. So when the place at which you are not finding the needle is the turbidity. That means if the water is clear, so you can dip the rod for a much deep, and you can see the turbidity there. The turbidity will be less there. For more turbid waters, even if you just dip it, then you will not see the needle. That is, it is more turbid. This was old. We used to do this previously. Nowadays, we have got good turbidimeters. So in with the help of turbidimeter, you can measure directly what is the turbidity of that particular sample. Well, how is this measured? It is when the water is when the particles in water interfere, which are interfering the passage of light waves, they get scattered in various directions. This scattering, the amount of scattering of the light is measured by a turbidimeter. We will see how we can use a turbidimeter to measure the turbidity. So let us go and see in a laboratory how this turbidity is, how the turbidity is measured using a turbidimeter. Here we have a
turbidity. There are some ranges in which this is 0 to 10 MQ.
Okay.
This is the range in it. We will start as the same thing in
This instrument.
with this
We can standardize this instrument in this range.
with the range.
In the 0 to 1000, and this is from 0 to 100. And
This is 0 to 10.
0 to 10.
If you more suppose if you give the turbidity is more, you have to start as using this solution. You have to standardize this instrument.
Okay.
This is the active meter. Put our 100 V. We have to use the sample.
Suppose this is the sample.
Suppose this is a sample of having certain turbidity with all particles, smart particles, all the things. First of all, we have to keep this sample in the angle having this side and keep it like this. And you close the lid. Then you have to make it power to this button.
Okay. Press power button.
Press power button. Then it will show 0.
Okay.
so this so once we will keep the sample, and then
This bottle is containing turbidity.
so once after we
red button, this will blink like this, and after a few seconds it will show the turbidity. It means this is 213 NTU of turbidity containing this sample. The sample is containing 213 NTU. Now flow turbidity units NTU units.
So that is how we will measure the turbidity in a sample. Then the next test that we go for is the color. The color is measured in
This is a blank water, distilled water taken in the. So I have to face outside this blank sample, and then this colored water we get sample. You will keep it outside. In the other side. For these are the colors. We have to calorimetric chart. This is called the calorimetric chart. With this chart, we have to compare the color with the chart of the sample and take the reading as having Hazen units. This Hazen units is given in this slide. First, we will compare with the colors. These are the colors. The sample is matched with the color. This color. So you have to remove also remove like this, and then fold this and see the Hazen units. The second one is 100 units. The second one is 100 units.
So the color is now having 100 Hazen units.
Yeah, 100 Hazen units. water, distilled water taken in the. This is a blank. This is a blank water, distilled water taken in the.
Now after measuring, what is a Hazen unit? Hazen unit is when you dissolve 1 mg of platinum cobalt salt in 1 liter of water, we will get 1 Hazen unit. That is the measurement of color. So this is the true color. So when even the turbid waters impart color to the water, but we should filter the turbidity, and then only you can measure the turbidity of the color of the sample. That is the true color. Then the next important test that we do, that is a physical test that we do, is the odor test. That is, when odor is when you smell, we will get some odor. So when it is we measure odor in threshold odor number. It has threshold odor number. Threshold odor number is the dilution ratio. Suppose if I add 50 ml of sample to 250 ml of the fresh water, then it loses its smell. Then that is called the dilution ratio. That is, it is 5 times. We are adding 5 times more the fresh water to lose its odor. So that is the 5 is the threshold odor number. That is how much minimum water, by adding what minimum amount of this smelly water to a sample, by diluting it, it is losing the smell. That we will measure the ratio, the dilution ratio, and that is the threshold odor number. The permissible limit for this threshold odor number is 3. Then the last test, that is the temperature. Temperature is of not very much significance. When the water is polluted by some industrial waste or something, it will generally get the temperature. The temperature of the water will be more. So that is these are the physical tests.
This is a blank water, distilled water taken in the. So about.
Now let us talk to regarding these what are the precautions taken by our metro waterworks. Let us talk to Sri K.S. Narsappa garu and see what they do for treating the water. He is Deputy General Manager of Hyderabad Metro Waterworks. Let us talk to him and let us get a broad overview of what they are doing.
Of the chemical parameters, they are the permissive limits. Then we can say the water is potable. Now, as I said, physically the water should be satisfied in the sense of the 3 parameters that are color, odor, and turbidity. Now, color means it should not have any color. Some water should be greenish, some will be brown because of the iron content. And greenish nature also, it is objectionable. So, what has to be extra clear. The second one is the odor. Odor means the water, if you smell, it should not have any smell. It should not be gassy smell or fishy smell. It should be clear with any smell. Then we say the water is good. Then turbidity. Any the suspended particles that are there in the water is called, we think it as turbidity, and it is measured in MTU, effluent turbidity units. So these are the three parameters which is done in physical analysis. We call it as the physical analysis. Then we go for the chemical analysis. The next part is the chemical analysis, in which we go for the pH, alkalinity, hardness, nitrites, chlorides, sulfates, and all the constituents, the mineral constituents that are there naturally in the water. We have to analyze them. So we have to know whether there are the limit, a permissive limit, certain standards are being given that should be in that standard. If they are more than that standard, we say it is objectionable, it cannot be used for the drinking purpose. Say, if you say water pH, it should not be below 7, it should be always 7, and that to the range of 8.5. Because if it is below 7, water is acidic, it is not used for drinking because it will affect your digestive system. That is, again, if you go for what is called the fluoride, the fluoride content should not be more than 1.5 milligrams per liter. If it is more than 1.5 milligrams per liter, you get what is a disease called fluorosis disease. Usually we have observed that in Nalgonda and districts where the groundwater is having a fluoride content of about, say, more than 5 milligrams per liter. So it is more than 1.5 milligrams per liter. If it is more than 5 milligrams, you get what is the disease called fluorosis disease. Nalgonda percussion districts, the fluoride content will be 5 milligrams, 10 milligrams like that. In those areas, you observe people who are 30 years will look like something like 60 years people. This is mainly because of the fluoride content in them. The bones will be bent, the backbone will be bent. So they look like very old age persons. This is mainly because of the fluoride content. This is the same case is also in percussion districts also, where the fluoride content is very high. Now if you go for another parameter, nitrate is another one. Nitrate should not be more than 45 milligrams per liter. If it is more than 45 milligrams per liter, so if that water cannot be used for babies who are below 5 years, because they get a disease called methanoglobinea disease.
As the disease is more downstream state.
This is a research done, this is observation. So as it is, we are more concerned for the city supplies. We don't have more products, but we are supplying all what is called from the sources of Mysore, Sankethika, and what is called Manjira Singapore, the groundwaters. The groundwaters will have a nitrate content. If that nitrate content is more than 45 milligrams, then the babies who are below 5 years will be affected.
So in the different states, there
may be by nature, but this is
settlement studies.
Yes, they will see that if that nitrate content is more than that, they will see that sources is disconnected. They don't supply the water. And another thing is sulfates. If sulfates are high, the intestine, your digestive system will be affected. The sulfate content is high. Say if the mercury is high in the water, then what will happen? The nervous system will be affected. Mercury is high. If chloride is also very high, so this is all the minerals which are. Yes, mercury.
Mercury did say specific instances like due to this mercury is high in these places, due to this mercury is not. Can you just give an example of this where mercury content is high?
Yes. Mercury content in the groundwater, there won't be any mercury, but only in the surface waters. Now that is mainly where we see if there is agriculture activity going around the sources, say from where you draw the water. In that case, where commercial crops are grown, and if commercial crops are grown, if the farmer sprays pesticides. Now pesticides will have very strong toxic metals in that. If that toxic metals are nothing but mercury, lead, arsenic and all that, will be chromium, all this will be there. And if that flows into the source by the runoff, the rainwater, and if that gets accumulated in the sources, then mercury content will be there. As it is, the water does not have any mercury, but because of the activities that are done in the surrounding areas, the mercury will just flow into that water. So in that way, it is a man-made activity because of which the mercury will get into the sources.
Then what about the distribution system? How is are there any chances of these content, these minerals getting increased like chlorides or something?
Now, as I said, if there is any industrial activity, say Patanjali is there, say LB Nagar is there, CS factory was there, because the CS factory was closed because of the groundwater being affected because of the effluent from that factory. The groundwater was affected, thereby the factory was closed. In Patanjali, if you go there, the groundwater will have a lot of toxic substances, lot of minerals, which cannot be used for drinking. They are not in the purpose limit, they are very high. So in that cases, the borewell cannot be used there. It should not be used and it cannot be treated also. The water cannot be treated if the mineral content is very high. Only the treatment is only for the suspended impurities. Next, that is the treating the water for bacteria. Bacteria, if there is any bacteria that is there, that can be killed and we can treat that water and then supply. But as it is, if very toxic metals or heavy metals come into the water, you can't treat it. It is not possible. The best possible way is prevention is better than cure. You have to prevent your sources. You have to see that none of the, as I said, no industrial activity should not be there in the vicinity of 10 kilometers range contaminated by some toxic metals or heavy metals like mercury, cadmium, all this. This comes by what is called like the runoff of the fields, rainwater running off through the fields. That means the surrounding areas where commercial crops are grown. Commercial crops means cotton, what is called tobacco, haldi. These are the commercial crops where the farmer expects some money, big money. So he goes to get a good crop. To see that no insects attack his crop. So he sprays pesticides. These pesticides will have a lot of toxic substances like mercury, cadmium, all that. So during the rainy season, because the runoff from these fields, the rainwater will flow from those fields and come and get accumulated in the source, and thereby the mercury and lead and all this will come into the source. So it is better that no commercial activity, commercial crops are not grown in that area. Go for other crops like paddy, jowar, or something which does not require very high pesticides spraying. So that is a better way of doing and protecting your source from entering the toxic metals.
Regarding distribution system.
So we have seen a small brief interview with Hyderabad Metro Water Works DGM. Now from this interview we can see that not only testing not only for physical impurities, testing for chemical impurities and bacteriological impurities also form a major part of our treatment plant. So now there are cases and there are many cases in various municipalities the water is getting chemically impaired. We will have to treat these waters for chemicals. Now what are the different tests that we do chemically are like testing for pH value, then the testing for alkalinity, acidity, and the total solids that are present in the water, and the various other chemicals like metals, iron, manganese, mercury, etc. All this we will have to treat the water chemically. Then the third one is the bacteriological impurities. Like before all this, we should collect the samples from the sources. Collecting the sample is very important. If you are collecting the sample for physical tests, then it is sufficient if a big plastic container, if you use a big plastic container and draw the sample from the source. Then the second one, if you are doing for the chemical test, you should use a glass jar such that it is clean. It is sufficient to carry 2 liters of water, and it should be thoroughly cleaned. Then in the same way, if you are using a if you are collecting sample for bacteriological tests, the sample, the bottle should be thoroughly cleaned with sulfuric acid and then potassium permanganate, and then only it should be kept in a hot air oven, that is to sterilize the water, and then only you can use that bottle for the sample. Then for collecting the sample, if you are collecting the sample from a tap, then you should leave the tap open for some time, such that all the bacteria or the rest, whatever it is attached to the tap, will go off along with the water. Then after you should collect the sample from the tap directly. Then afterwards, if you are collecting the sample from a source, you should first first decide what is the type of sample which you require. Is it the sediment? Is it this? You can divide it into 3 layers: the floating layer, the suspended layer, and the settled layer. So you can take, if it is from the source, you should know which water you want to collect it. Then if you are collecting the sample for the bacteriological tests, there is you are using a sterilized bottle, you should leave the tap for some time, then you should collect the water. Then afterwards, immediately you should close it with a cloth and tie it. Then you should preserve, if you are going to do the test after some time, you should preserve the sample for some time, then only preserve the sample carefully in a fridge, then only you should use. Otherwise, you should immediately do the bacteriological tests. Otherwise, the bacteria will develop, the new bacteria will be developing in the, it will not show the real sample value. So, and some part of it, the bottle should be left open, it should be free, so that the bacteria will have the air, then the sample will be a little fresh. So now we have seen, in today's session, what we have seen is what are the different impurities present in the water, what are the different classification of the impurities, then what are the different physical tests using different instruments we have seen, and then how to collect a sample, how to collect the water from different sources we have seen.